Now another set of terminology we can use for this is the idea of agents. Okay, you often hear something as an oxidizing agent or an oxidizer, and what that implies is that it will remove electrons from a species. So back to our sodium and chloride example. Okay, we know that sodium is oxidized, chlorine is reduced. So another way you can ask that question, if sodium is oxidized, what oxidized it? What took its electrons, essentially? So since sodium is oxidized and chlorine got its electrons, chlorine is the oxidizing agent. Okay? If chlorine is reduced, what reduced chlorine? What gave it electrons? And that, of course, is sodium. So you have a sort of reverse nomenclature name change when you're referring to the agent. The element that the reactant that reduces an element is referred to the reducing agent. The other way to think about this, the reducing agent is always the element that's oxidized, and the oxidizing agent is always the element that is being reduced. Okay? So let's take a look at this. Let's determine the oxidation states so that we can determine what element is oxidized and, of course, what the agents are. Okay? So here we're just going to do the same type of work. We're going to go through and determine the oxidation states of these. Okay? This is iron by itself. Probably should have a solid there. So that's going to be 0. We know that we're going to apply oxygen minus 2. Oxidation state there from our rule number 5. Okay, there's 4 of them with an overall minus 2 charge. With the 4 of them with an individual minus 2 charge, we know that has to equal minus 1 because of its charge. So, what is the charge on that manganese atom? Okay, well, if that's minus 8, this has to be plus 7. H plus by itself, that's a plus 1. Because, you know, the oxidation state has to equal the overall charge. Same thing with iron 3 plus, oxidation state plus 3. Oxygen, we're going to apply our minus 2. There's 2 of them. Minus 2, we know that has to equal 0. And so, what does our manganese have to be? That has to be plus 4. And then finally, we've got our water again, and minus 2 for the oxygen will give us our plus 1 for the hydrogen. Okay. So what has changed? Manganese went from a plus 7 to a plus 4, and then iron went from a 0 to plus 3. Manganese went from a plus 7 to now only has 4 more protons than electrons, so this has gained 3 electrons. And of course, if iron starts at 0, suddenly has a plus 3 charge, it definitely lost 3 electrons. Okay? So if we're gaining electrons, this is our reduction, the GER part of asking Leo. And this is our oxidation reaction. Okay? And so we can also think about now, what is my oxidizing agent? Okay, it is the element that's being reduced, so that's manganese. And then my reducing agent is the substance that's being oxidized, and that is iron. Alright, here's a couple of another couple of examples that are quite simple, but we'll still just get a little more practice here. Okay, 10 plus 4 is of course 4 plus, or plus 4 oxidation state. Calcium by itself is 0. 10 plus 2 is plus 2, and of course calcium plus 2 is plus 2. So we only have 2 species here, so we know they had to change. Okay, 10 going from a plus 4 to a plus 2 indicates that it lost electrons. And, indicates that it gained electrons. It has gone from a scenario where it has 4 more protons to only 2 more protons, so it gained electrons. electrons. And of course, if calcium goes to a +2 cation, we know that it lost electrons. Okay, so this is my reduction reaction. Tin's being reduced, calcium's being oxidized. And then, of course, the reverse is true. Tin is my reducing agent. And then calcium is my oxidizing agent. Oh, excuse me, I made a mistake again. Tin is my oxidizing agent. And then calcium is my reducing agent. Okay, another short little example, but we're going to now need to use that table. Okay, if we try to figure this out, okay, fluorine by itself is a 0, sulfur by itself is a 0, and now we have sulfur tetrafluoride. Okay, and we just, well, we can use some of our information. We know that fluorine likes to form -1 ions, sulfur likes to form -2 ions, but we know that can't work because a -2 and a -1 ion wouldn't form a compound, and the sum of those oxidation states wouldn't equal its charge. So we have to go to our rules or our table to determine the overall change in oxidation state here. So fluorine and sulfur are 0 on the reactant side. We're going to apply a -1 to fluorine first, -1, and then down here sulfur gets a, it actually wouldn't get a -1 because it's way down here. Because fluorine is first, we're going to apply that to the compound, and now sulfur takes on a oxidation state that can be determined by the fact that, okay, we've got 4 -1s, this is going to equal 0. So what is the oxidation state on that sulfur atom? Okay, and that has to be +4. Okay, so fluorine gained electrons, sulfur lost electrons. Okay, so this is going to be my reduction reaction. Sulfur will be my oxidation reaction. And so that means that my reducing agent is sulfur, and my oxidizing agent is fluorine.